Okie dokie. Hello. Hey, all you cool cats and kittens. If you haven't watched that show yet, it's something else. Okay. But anyway, today we are going to be finishing our notes. So we're going to finish this chapter, and then we have one more chapter after this, and then you're done for the year, which is crazy. So let's go ahead and get started. We're talking about fission and fusion today, and I hope those sound somewhat familiar to you guys. Hopefully it's not the first time you've heard those words. But let's go ahead and get started. I don't want my... Okay, so we've got numbers 49, which is a little hidden. It's on top of that picture there. 49 through 52. 49 through 52. So the first thing we need to talk about is fission. So the root word of fission, fis, F-I-S-S, that means to break apart. And that's exactly what nuclear fission is. So the nucleus gets split into smaller fragments. So we can see here we have an atom, and then it gets broken apart. And what that releases is a bunch of energy. So all those nuclear power plants that we have around the world, they create energy by using nuclear fission. So it releases quite a bit of energy. So basically you have an atom, it gets hit by a neutron, and that breaks it apart and then makes smaller atoms. So it can release a lot of energy, like we said. It is uncontrolled, so that's one issue with working with nuclear power plants, is that you can't really control it if it gets out of hand, and it releases a lot of energy in fractions of a second. But one nice thing about nuclear fission is that it's actually a very clean way to produce energy. It actually currently produces about 10% of the world's energy. Some countries are different. The US has quite a bit of nuclear fission. Some countries in Europe have up to 50% of their energy created by nuclear fission. So even though it might sound kind of scary, working with nuclear power plants, it's actually quite a pretty good alternative to clean energy, as long as you can keep it controlled, not be like Chernobyl, and keep things running well, because it does create quite a bit of energy. So fission, things are being broken apart. Oopsies. So we've got number 53. So fission can be controlled if you have the right equipment, so that it doesn't release too much energy at once. So it can release energy more slowly. And this is what's happening inside of nuclear reactors, inside of nuclear power plants. It kind of helps to control it, so it's not just like all this energy at once and we can't use it because it's all gone. You're like, where'd it go? So it kind of slows it down so that it can be used to power homes and businesses and things like that. So here's kind of an example of what is going on in a nuclear power plant. So we can see we have these reactor. This is the fuel rods. That's where the fission is taking place. And then it gets turned into heat, basically creates all the steam, and then it needs to cool it off so that it doesn't go out of control. That's part of the issue with things like Chernobyl, or nuclear power plants like Chernobyl, 3 Mile Island, places like that. They had malfunctions happening. So, but if everything's working well, it actually creates a lot of really good, useful energy. So they're actually quite useful. So nuclear fusion is different. So fission is where things are breaking apart. Fusion is where things come together. So this is 54 through 56. So 54 through 56. So fission, as we said, creates quite a bit of energy, but nothing compared to nuclear fusion. Fusion creates way more energy, so much energy. This is how the sun creates its energy. So in the sun, basically what's happening is that it is bombarding 2 hydrogen atoms to create the larger helium atom. And if you take geoscience, which you all should, we go way more into detail with that. So that is how the sun powers itself. And as we know, the sun creates a lot of energy, and it's been doing that for billions of years, about 4.5 billion years. So it's an enormous amount of energy that is created. So the nuclei combined to create one larger atom. So like we said before, fission creates a lot of energy, but it's got nothing compared to fusion. Fusion creates a lot of energy. And we can see right here, we got the small atoms, and it creates a large atom and a lot of energy. So currently, humans do not know how, or they can't create fusion in the laboratory yet, or at least not super effectively. But if we were to figure out how to do fusion, that would probably, actually, that would solve all of our energy problems. And then we wouldn't have to rely on coal, gas, other things like that. If we could figure out how to do fusion on a large scale, very productively, then we would be good to go. And like I said, like this is a really good, clean, green energy option here. The sun's really good at it, and it's been powering itself for billions of years. But like I said, the only issue is that it's really hard to do it. And the sun, it has a very, very high temperature, as I'm sure you know, and a very high pressure inside of its in its core. So we haven't quite been able to reproduce those conditions, but future scientists of America, you guys should work on that, because like I said, it is an amazingly huge amount of energy it can create, and it would fix a lot of issues, a lot of energy issues. So fusion's awesome. Fission's great. Fission is amazing, but fusion is just like on a whole nother league. It's just really awesome. So fission, things come together. Fusion, or sorry, break that up. Okay, fission, things get broken apart. That's it. Fission, breaking apart. Fusion, things come together. So you could think of things being fused, they come together. So fission, breaking apart, fusion, coming together. Okay, and the last thing we're going to talk about is number 57. And hey, we're done with this chapter. But the last thing we'll talk about is how we can actually use radiation. This whole time we've been talking about, like, you know, the radium girls and everyone dies, and, you know, Marie Curie died from radioactivity, and it's very destructive if you don't know how to use it properly, but it can also be used safely. So we can analyze matter with it. We can study how plants grow, treat diseases, diagnose medical problems. Those last two are probably the most important ones that we're probably aware of. So here we have an image. So this is a person here. So this is their shoulders. This is their head, other shoulder. So this mass right here, that is a thyroid tumor in their thyroid, right in their neck. So they were able to discover that by using these radioactive materials. So it's kind of interesting that radioactivity can cause cancer because it can destroy your body, or it can help find medical problems, and it can actually help treat it. So a lot of people that have cancer, they will go under radiation, right? Radiation therapy. So basically they can use gamma rays to shoot the tumors, and it will actually destroy the tumors. So even though it can cause cancer, it can also help cure cancer. Well, not cure it, but I guess get rid of tumors. So kind of interesting how it's almost a double-edged sword a little bit there. So radiation, it seems kind of scary, but it's also extremely useful. So anyway, your test, make sure you guys are studying for that. And I hope you guys have a great day.